Hello students, in the previous class we saw how to factorize polynomials by splitting the middle terms. Now let's look at the other method, which is using the factor theorem. So what exactly is the factor theorem? It says that if px is a polynomial with degree greater than or equal to 1 and a is any real number, then x minus a is a factor of px if pa is equal to 0 and pa is equal to 0 if x minus a is a factor of px. So this theorem works both the ways. You can say this is the theorem and this is the converse. Okay. So let's prove the first part. So by remainder theorem, what does the remainder theorem say? If px is your polynomial greater than or equal to 1, okay, and a is any real number, then x minus a into gx, where gx is any polynomial, the remainder will be pa, right? Now in this case, if pa is equal to 0, you get px is equal to x minus a into gx, right? So now px is written as a product of two terms, x minus a and gx, which means both these terms individually are factors of px. Therefore we had to prove that x minus a is a factor of px, right? So we have proven that x minus a is a factor of px. So this was your first part. Now let's look at the second part, which is the other way around. Now if x minus a is a factor of px, right? If x minus a is a factor of px, we can write px as a product of x minus a and any other polynomial, let's say gx, right? Now in the case where x is equal to a, right, what do we get? pa is equal to a minus a into ga, right? A minus a will give you 0. So 0 into ga will give you 0. Hence we have proved the other way around as well. That is, pa is equal to 0 if x minus a is a factor of pa. So with this we have studied both the methods of factorizing polynomials. One is by splitting the middle term and one is by the factor theorem. We will go ahead and solve certain solved examples of your textbook. So the question says examine whether x plus 2, this is example 11, sorry. Examine whether x plus 2 is a factor of your polynomial x cube plus 3x square plus 5x plus 6 and as well as another polynomial 2x plus 4. So let's say I call this polynomial px and this polynomial as sx, right? So we have to examine whether x plus 2 is a factor. So we will first find the 0 of x plus 2. 0 of x plus 2 is minus 2, right? How? X plus 2 is equal to 0, therefore x is equal to minus 2. I am going to substitute the value of x is equal to minus 2 in these two polynomials. So let's say for p minus 2, if you get the answer as 0, then x plus 2 will be a factor of px. If you get any other value apart from 0, then it won't be a factor. Let's check. So minus 2 cube plus 3 into minus 2 square plus 5 into minus 2 plus 6. This is minus 8 plus 3 into 4 plus 5 into minus 2 will give you 10 plus 6, right? So this is minus 8 plus 12 minus 10 plus 6, right? So this is nothing but you add the negative terms. So this gives you minus 18 and you add the positive terms which will give you plus 18, which is equal to 0. Therefore, x plus 2 is a factor of this polynomial px. Now let's check whether x plus 2 is a polynomial of Sx or not. Again, s of minus 2, we will substitute the value of x, which is minus 2, in this polynomial. So it becomes s of minus 2 is equal to 2 into minus 2 plus 4, which is minus 4 plus 4, which is equal to 0. So finally you will write that yes, x plus 2 is a factor of px and sx. Let's proceed with the other example. Find the value of k if x minus 1 is a factor of 4x cube plus 3x square minus 4x plus k. Okay, you need to find the value of k if x minus 1 is a factor of this. Now since we know that x minus 1 is a factor of this polynomial, let's say px, the 0 of polynomial, which in this case is 1, when substituted in this polynomial will give you 0, right? So p of 1 will be 0. By factor theorem, since x minus 1 is a factor of px, p of 1 is equal to 0, right? Now p of 1 is nothing but 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k, which is equal to 0, right? So 4 into 1 will give 1 cube is 1, which is 4 into 1. So 4 plus 3 into 1 gives me 3 minus 4 plus k is equal to 0, right? Plus 4 and minus 4 will cancel out. So you have 3 plus k is equal to 0, right? Therefore, I'll just write it here, 3 plus k is equal to 0. Therefore, k is equal to minus 3, right? We will go ahead and solve the other examples as well. Let me quickly erase the board for you. Factorize. This is example 13. 6x square plus 17x plus 5 by using the factor theorem. So let's say I name this as my solution. So let us name a polynomial px as 6x square plus 17x plus 5, right? Now I have a coefficient attached to the first term, so I am just going to take that outside. This makes it 6, the entire bracket, x square plus 17 upon 6x plus 5 upon 6. Now why 17 upon 6 and 5 upon 6? You open the brackets and you will find out that eventually you will get 6x square plus 17x plus 5. This is my polynomial. Now, if a and b are zeros of px, that is polynomial, this polynomial, then px can be written as px is equal to 6 into x minus a into x minus b, right? Which means nothing but a into b is equal to 5 upon 6 according to the factor theorem. So, a into b is equal to 5 upon 6. So, now we have to take into consideration the possible factors of 5 upon 6, substitute in this equation, and then you will be able to find the factors. So, the factors of 5 upon 6 can be possible factors. So, let us find the possible factors of 5 upon 6 first. So, 5 upon 6 possible factors can be, see 5 upon 6 can be written as 5 upon 2 into 3, right. So, the possible factors can be 1 upon 2, because 1 upon 2 into 5 upon 3 will give me 5 upon 6. So, here are your possible factors, plus or minus 1 upon 2, right. Similarly, if I take 1 upon 3 and multiply it by 5 upon 2, you get 5 upon 6. So, another possible factor is plus or minus 1 upon 3. Similarly, you have 5 upon 2 plus or minus, right, and if you take 1 upon 2, the other factor is 5 upon 3. So, plus or minus 5 upon 3, right, and obviously plus or minus 1. So, these are the possible factors of 5 upon 6. Now, I am going to substitute, use the hit and trial method, substitute the value of x is equal to minus half, plus or minus half, plus or minus 3, and just see whether which one satisfies the equation to give you the polynomial as 0. Okay. So, let us take the first one, p of minus half. P of minus half can be written as 6 into minus half the whole square plus 17 upon 6 into minus half plus 5 upon 6, right. So, this can be written as 6 1 upon 4 minus 17 upon 12 plus 5 upon 6. Now, you need to take the LCM. We know that LCM of 4, 12 and 6 is 12. So, I am going to multiply this by 3 and this by 3, this by 2 and this by 2 to have a common denominator so that we can add. So, this is going to be upon 12, 3 minus 17 plus 10, right. 6 1s are 6, 6 2s are 12. Now, 3 plus 10 is 13, 13 minus 17 will give me minus 4 upon 2, right. 2 1s are 2, 2 2s are 4. This is equal to minus 2, which is not equal to 0, right. Therefore, x plus 1 upon 2 is not a factor of this polynomial. Why x plus 1 upon 2? Because minus half would have been the 0 of, minus half would be the 0 of the polynomial x minus 1 upon 2. Let us check for 1 upon 3. P of 1 upon 3. So, do you notice that we are using the hit and trial method, whichever one of the factor works, that will be, whichever of the factors of 5 upon 6 works, that will be one of the factors. We will substitute in this equation x minus a and find the other one. Okay. So, this is 6 into 1 upon 3 the whole square plus 17 upon 6 into 1 upon 3 plus 5 upon 6. Now, it is very obvious that everything is going to add up, nothing is going to get subtracted. So this is not going to be equal to 0, right? So this is again not going to be a factor, x minus 1 upon 3, right? Let's check p of minus 1 upon 3. Substituting x is equal to 1 upon 3, you get p of minus 1 upon 3, 6 into minus 1 upon 3 the whole square plus 17 upon 6 into minus 1 upon 3 plus 5 upon 6. So this will be 6 into 1 upon 9 minus 17 upon 18 plus 5 upon 6. Now let's take the LCM of 9, 18 and 6. What do we get? You get 2, 9 comes as it is, 2 9s are 18, 2 3s are 6. And the LCM of 9, 9 and 3 is 9. So the LCM is 18. So this we will multiply 9 into 2 into 2, 18 1s are, 6 3s are, 5 3s are, right? So 6 into 2 minus 17 plus 15 upon 18. This is 17 minus 17. So you get 6 1s are 6, 6 3s are 18 and 0 upon 3, which is equal to 0. So yes, this condition is satisfied, that is p of minus 1 upon 3 is equal to 0, right? Therefore, x plus 1 upon 3 is a factor of this polynomial. Similarly, we have found one polynomial, that is x minus a. Let's find for x minus b. Like we saw earlier, if you are taking a positive factor, everything turns out to be positive here and you won't really be able to get the polynomial as 0. So let's take minus 5 upon 2. Okay, so p of minus 5 upon 2. First of all, x in minus x plus 1 upon 3 was a factor, right? I'll write this as factor 1, or I'd rather write it below this one, x plus 1 upon 3, right? Now you need to find x minus b. So p of minus 5 upon 2 is going to be 6 into minus 5 upon 2 the whole square plus 17 upon 6 into minus 5 upon 2 plus 5 upon 6, right? So this is 6 into 25 upon 4, right? 17 into 5s are 5 7s are 35, 5 1s are 5, 6 7 8. So minus 85 upon 12 plus 5 upon 6. Again you need to find the LCM of these three terms so that you can add the numerators. So you have 4, 12 and 6. You have 2 2s are 4, 2 6 are 12, 2 3s are 6. 2 1s are 2, 2 3s are 6, 3 and 3 1s are 3. So the LCM is 2 2s are 4, 4 3s are 12. So 4 into 3 will give me 12, 25 into 3, 6 into 2 and 5 into 2. So 6 into upon 12, 25 3s are 75 minus 85 plus 10. 6 1s are 6, 6 2s are 12. 75 plus 10 gives you 85. So plus 85 minus 85 will give you 0 upon 2, which is 0. Therefore, p of minus 5 upon 2 is equal to 0. Therefore, we have found the other factor x minus b, which is x minus of minus 5 upon 2, which is x plus 5 upon 2. Therefore, your polynomial px can be rewritten actually as px. Let's just write how it was given. Px is equal to 6 into x minus a into x minus b, right? So I am simply going to substitute the values of x minus a and x minus b over here. So this is going to be 6 into x plus 3 upon 2, x plus 1 upon 3 and x plus 5 upon 2, right? We can further simplify this. So the LCM here is 3 and LCM here is 2. So I multiply this one by 3 and this one by 3 and this one by 2 and this one by 2. So what do I get is 3x plus 1 upon 3 and 2x plus 5 upon 2, right? Now we can simply divide. 3 ones are 3, 3 twos are 6, 2 ones are 2, 2 ones are 2. So finally we have our factors as 3x plus 1 into 2x plus 5, right? So this is your px, which is nothing but 6x square plus 17x plus 5 is equal to 3x plus 1 and 2x plus 5. So the factors of 6x square plus 17x plus 5 are 3x plus 1 and 2x plus 5. This is a very important and a tricky sum. So I suggest you keep trying this because it will come only through practice. We will continue with the solved examples in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.